Hello students, today we are going to discuss network analysis, determination of critical path. And that is how to determine the critical path of a network project. When you draw the network diagram, you have to determine the critical path, and how to do that. How do we determine the critical path? So that is our topic of discussion today. But before we start discussing this topic, how to determine the critical path, let us go back to our last class and let us see what we discussed in the last class. Well, this is this. In the last class, we discussed about what is network analysis. We defined that, we understood that. Then we discussed about difference between critical path method and program evaluation and review technique. We understood that. And we also discussed rules of drawing network, rules of network construction, how to construct a network, how to draw a network diagram. We understood the rules and we learned that. In today's discussion, today we will apply all these rules we understood, we learned in the last class when you draw a network and we try to find out the critical path of that network. So today's discussion is about determination of critical path of a network, right? See, in a network diagram, you have a number of critical paths. You have only one critical path and you have number of paths start to finish. Start to finish, you have number of paths, and out of that, one is critical path. If we define the critical path is the longest path through the network diagram. Critical path is the longest path through the network diagram, and the total time or duration of that path is actually the time of duration of the project, and that is called critical path. So to define the critical path, let us define critical path this way. Critical path is the longest path. It is the longest path through the network diagram. So what is critical path? It is the longest path through the network diagram. In a network diagram, you will have number of paths from start to finish, but the longest path of all of these will be the critical path. That is the simplest definition of critical path, and if you want to find out the critical path, that's the simple method to find out the critical path. How? You find out the duration and time of each of the paths and find out the path which has the longest time and longest duration. So this is the definition of critical path, and all activities in the critical path will be called critical activities. This is also, you should know, all activities on the critical path are called critical activities. All activities on the critical path are called critical activities. All activities on the critical path are called critical activities. Other activities of the project are called non-critical activities. Okay? So, important understanding, what we have understood, the important thing, critical path, it is the longest path through the network diagram. You have number of paths from start to finish of a network diagram, number of paths, and out of all these paths, the longest one will be called critical path. Longest one means the path which will have maximum time to finish, to complete the journey from start to finish. This is the longest path, that will be called critical path. All activities on the critical path are called critical activities, and other activities on the project are called non-critical activities. Okay, fine. Now, let us understand. So, obviously, you have understood that there are two methods of finding critical path. One is find out paths, duration of all the paths, and find out the path having the longest duration. So, applying this first method, we can find the critical path of this network diagram. Of this network diagram, you have paths. These are the paths. This is one path, right? This is another path, right? And this is another path. This is another path. This is another path. So these are the paths from start to finish to complete the project. So you can complete the project. So these different paths from start to finish. Let us find out time taken by each of the paths to finish the project, to complete the project. Let us draw this chart to find out the longest path among all the paths. Okay? The chart list will look like this. Path, activities, and length. Path, activities, length. Paths So you have paths. First, the path will be 1, 2, 5, the node number. I am here speaking out the node numbers. Oh, one more thing, friends. I have to discuss about the node structure, anatomy of node. I have to explain the anatomy of node before I go into the details about finding the critical path. See, this is node. We have understood in the earlier class what is node. These are the nodes or events. Okay, first node, second node, then this is third node, fourth node, fifth node by the name of the node. So this is the anatomy of node. When you draw a node to find the critical path, you draw the node this way. Draw this T. It's a T shape in between, inside the node circle. Inside the node circle, you draw the T shape, and this half circle will have the node number. What this half circle above is the node number. Will have the node number. This is the node number 1, node number 2, node number 5, like that. And below, the lower part will have two equal parts. This is the upper part, this is the lower part of the node. And the lower part of the node, the circle, will have two parts, the left side and right hand side. In the left hand side will indicate the earliest start. What? The earliest start. The left side of the lower part of the node will indicate the earliest start, and the right side of the lower part will indicate the latest finish. What? Earliest start and latest finish. Okay? So this thing we'll keep in mind, and we'll remember when we apply this understanding when you draw the network, and we'll know draw the critical path, find out the critical path. So this is important. The anatomy of node, which has upper part and lower part. Within the circle, upper part will have the node numbers, and lower part, again you have two sections, the left and right. In the left section you will put the earliest start time. In the right hand section you will put the latest finish time. Clear? Okay. Now the paths. The first path will be 1, 2, 5, 7, 8. 1, the node number 1, node number 2, node number 5, node number 7, node number 8. The path will be 1, 2, 1, 2, 5, 7, and 8. Okay, this is the first path. 1, 2, 5, 7, 8. Now the second path. Second path, 1, 3, 5, 7, 8. This was 1, 2, 5, 7, 8. Now you have 1, 3, 5, 7, 8. Clear? 1, 3, 5, 7, 8. This is the second part. 1, 3, 5, 7, 8. The next one, obviously this is the stage 1, 3, 7, 8. So next, third, 1, 3, 7, 8. And then the next one will be what? Obviously next one will be this. 1, 3, 6, 8. 1, 3, 6, 8. And the last one, the remaining path, 1, 4, 6, 8. 1, 4, 6, 8. 1, 4, 6, 8. Right? So we have path 1, 2, 5, 7, 8. 1, 2, 5, 7, 8. 1, 2, 5, 7, 8. We are reading it. Then we have path 1, 2, 5, 7, 8. That was 1, 2, 5, 7, 8 and 1, 3, 5, 7, 8. So we are reading it 1, 3, 5, 7, 8. Next one, the state 1, 3, 7, 8. 1, 3, 7, 8. So we are reading it. We are 1, 3, 7, 8. The next one is 1, 3, 6, 8. 1, 3, 6, 8. We have written this 1, 3, 6, 8, right? And the last part 1, 4, 6, 8. 1, 4, 6, 8. And we have also written this 1, 4, 6, 8. Obviously, you can also identify this path by activities. So these are the node numbers and these are the activities. By activities also we can identify the paths. Right? So the first path, this one, 1, 2, 5, 7, 8 by node numbers, and by activities A, D, I, K. Right? A, D, I, K. So we write it A, D, I, K. A, D, I, K. And the next one, 1, 3, 5, 7, 8. So this is by node number, and by activity it will be B, E, I, K. But B, E, I, K. So write it B, E, I, K. B, E, I, K. Okay, by activity. And then the next path by node was 1, 3, 6, 1, 3, 7, 8. 1, 3, 7, 8, the state. That was the path by node. Now by activity, this is simply B, G, K. So write it B, G, K. B, G, K by activities. The next path was 1, 3, 6, 8 by node numbers, and by activity now we'll call it BFJ. Simply BFJ. BFJ by activities. The path by activities BFJ. The last path was 1, 4, 6, 8 by node numbers 1, 4, 6, 8. That was the path by node number, and now by activity this will be CHJ. Simply CHJ. So these are the paths by node numbers, paths by activities. Right? 1, 2, 5, 7, 8 path by node numbers A, D, I, K by activity. 1, 3, 5, 7, 8 by node numbers, by activities B, E, I, K. 1, 3, 7, 8 by node numbers B, G, K by activities. 1, 3, 6, 8 by node numbers, and by activities it is BFJ. And the last one 1, 4, 6, 8 CHJ by activities, the path. Now let us find out the length of all these paths. Each of these paths, find out the lengths. So lengths we will find by adding the duration that given here. Activity A has duration in terms of 2 days. If it is days, so 2 days, let us say it is days. Activity D has 3 days duration. Activity I has 2 days duration. Activity E has 6 days duration. By adding this duration or days, number of days, we will find the length of the paths, each paths in terms of days. So let us find the duration of first one, 1, 2, 5, 7, 8. 1, 2, 5, 7, 8. By adding all these, see 2 plus 3 plus 2 plus 6, 5, 7, 6 plus 6 is 13 days. So length is 13 days. Then the path BEIK. BEIK. Length is 7 plus 6 plus 2 plus 6. 7 plus 6, 13 plus 2, 15 plus 6, 21. So 21 days. Then 1, 3, 7, 8 BGK. BGK, the straight line, straight one. 7 plus 4 plus 6 days. So total 17 days. Next, 1, 3, 6, 8. 1, 3, 6, 8. How many days in this path? 7 plus 10. 17 plus 5, 22. So 22 days. So here you have 22 days. The duration of this path is 22 days. Okay. Now the last one, CHJ, by activity, the path. What is the duration of this path? 8 plus 6 plus 5, 19. 8 plus 6, 14 plus 5, 19. So 19 days. So duration of this path is 19 days. 19 days. So students, we have identified the length of each of the paths in terms of days, length or duration or time. So length is actually, you can say, time or duration. These are actually time or duration. Time or duration. So time or duration or length of each of the paths. The first one 13 days, 21 days, 17 days, 22 days, 19 days. So obviously now you can identify the critical path. You know exactly which one is the critical path. Since this path 1368 BFJ has highest number of days, maximum number of days, 22 days, this is critical path. This is critical path. 1368 BFJ having 22 days is critical path. We can call it simply by CP. This is the critical path. So this is one way of finding the critical path out of all the parts of the project network. Okay, now we'll understand the other method. The other method, the sophisticated method, the most popularly used method and most effective method. See, in a long project, you can calculate long duration project. You can calculate this by calculating the time of all the parts, all the activities actually. So. And another sophisticated method to learn, to understand, to identify the critical path is, which is most popularly used, we'll calculate, we'll see that. So to understand that, obviously you have to draw this network diagram first with all these nodes and node numbers and activity duration, activity number, activity duration, activity number, activity duration, and node number and node. So at this stage actually you have to find the earliest start and earliest finish. The first step, using the second method, we have already understood the first method, how to find the critical path, the longest path having the longest duration, the critical path. But this is the second method. In the second method, the first step, obviously draw the network with ES and LF. Now, what is ES and LF? ES is simply earliest start, LF is latest finish, earliest start and latest finish. But the point is, how to find out the earliest start and latest finish? We'll see that. Draw the network diagram as above and fill up the nodes stated earliest start and latest finish found by forward pass calculation. So here you have two terms or two methods, two stages you can say, forward pass calculation and backward pass calculation. What are these and how these techniques are used to find out the earliest finish and earliest start and latest finish, earliest start and latest finish. To find out earliest start and latest finish, you have to apply forward pass calculation, backward pass calculation. Actually, forward pass calculation is used to find out earliest start. To find out earliest start. To find out earliest start, so every node you have two sections in the lower part. See, in this node you have 2 and 11. 2 is the earliest start and 11 is latest finish. We will have to have this information when you try to find out the critical path method, critical path, this second method. So by forward pass calculation, you try to find out earliest start. Earliest start is found. Earliest start of every node. Every node has earliest start and latest finish, right? To find out earliest start, you apply which method? Forward pass method. And to find out the latest finish of every node, you apply which method? You apply backward pass calculation. You apply backward pass calculation to find out latest finish. To find out latest finish, you apply backward pass calculation. Okay? Now let us see what is forward pass calculation, backward pass calculation. Let us see in details, little bit in details. Okay? So for that you have to draw this network diagram again. You have to reproduce this network diagram. To understand this better, so let us draw. Just follow how I am drawing all these things. Okay, after we have done this much, let us put the node numbers, earliest start, latest finish and activity duration and all that, right? First, let us put the activity durations with activities. This is activity A. This is activity A with duration 2 days. This is activity D with duration 3 days. This is activity E with duration 6 days. Activity B, duration 7 days. Activity 8, this is activity C with duration 8 days. Activity H with duration 6 days. Activity F, duration 10 days. Activity J, duration 5 days, right? Activity I, this is activity I which has duration 2 days. This is activity G which has duration 4 days. And the last one, this activity K, has duration of 6 days. So these are the activities and duration of the activities. A 2 days, D 3 days, I 2 days, K 6 days, B 7 days, F, this is E, this is E, activity E has duration 6 days, activity G has duration 4 days, activity F 10 days, activity H 6 days, activity J 5 days. Okay. Now put the node numbers inside the circles and try to find out the earliest start and latest finish by using forward pass and backward pass calculation. So put the node numbers first. I told you you have this T shape. So write okay. This is how it looks now. Okay. So you find earliest start by forward pass calculation and find the latest finish by backward pass calculation. Forward pass starts with the first node or first event and finishes with the last event, last node. And backward pass starts with the last event or last node and finishes at the starting node. This is the starting node, this is the ending node. So backward pass starts from ending node of the project and finishes at the starting node of the project. While in the forward pass, you start with the starting node and finish with the finishing node. So to find out earliest start of each node, we'll take up the forward pass calculation. We'll take up the forward pass calculation. By forward pass calculations, you find out earliest starts. By backward pass calculations, you find out latest finish. So let us do that. So in forward pass, you put 0 here. The left hand side of the lower part of each node is for earliest start. So earliest start, put 0. And keep on adding the duration and put the figure in the left hand side of the lower part of node, right? 0 plus 2, 2. Then 0 plus 7, 7. Right? 0 plus 8, 8. Now, one tricky issue is after this node. In fact, I have to put the node number also. I have not put the node number. So first I have to put the node number. This is node 1, first node. The second node. This is called third node. This is fourth node. And this is fifth node. And this is sixth node, seventh node, and node number 8. So these are the nodes by number. First, second, fifth, 7, 8, and first, third, 7th, and 8th, first, 4th, 6th, and 8th. These are the nodes. Now, the tricky issue is when you see, I have done what? 0 plus 2, 2. Now, when you put the earliest start, when you put the earliest start for this node, earliest start of this node may come 7 plus 6, 13, as I have done 0 plus 2, 2, and here 2 plus 3, 5, right? 2 plus 3, 3 days, 2 plus 3 days, 5 days, and 7 plus 6 days, 13 days. So which one you should take? Remember, in forward pass, you always take the higher one or highest one. When you have merge activities, here you have the merge activities. Two activities have merged in this node. In forward pass, if you have a merged node where number of activities have merged, this is the merged node, right? You remember I discussed merged node, burst node. So this is the merged node where you have two activities merged. In this case, you will have conflicting earliest start. Like from this node to this node, you have earliest start for this node is 7 plus 6, 13. And if you come by this way, the earliest start will be 2 plus 3, 5. So remember, when you do this forward pass calculation, in this situation you will take the highest one among the conflicting earliest finish, among the earliest start. Among the conflicting earliest starts, you have earliest starts for this node is 13 and as well as 5. So this conflicting situation having number of earliest starts for this node, you will take the highest one. So which is the highest one? 13. Remember, so put 13 here. 13. Now, see again the same situation comes for this node also. 13 plus 2 is 15, whereas 7 plus 4 is 11. So what do you take? You take 15. You take 15. For this node also, you will have the same situation. 7 plus 10, 17, whereas 8 plus 6 is 14. So what do you take? You take 17, the highest one. Right? You take 17, the highest one. 17. For this also, the same situation. 15 plus 6, 21. 17 plus 5 is 22. So which one you take for this node? Earliest start? Earliest starts for this node will be the higher one, the highest one. 15 plus 6, 21, and 17 plus 5, 22. So it will be 22. Okay, understood? During forward pass calculation, for a particular node, if we have conflicting situation of having number of earliest starts, I repeat, during forward pass calculations for a particular node, if you have conflicting situation of having number of more than one earliest starts, you will take the highest one. Clear? So this way we have completed the forward pass and calculating the earliest start of each node, which are 0, 2, 13, 15, 22 this way, and 0, 7, 15, 22, 0, 8, 7, 17, 0, 8, 17 and 22. Now we will start the backward pass. During forward pass calculation, we started from the starting node and end up with the ending node of the project. Now during backward pass, we'll start here. We'll start here at the finishing node of the project and end up with the starting node of the project. So when you start the backward pass, you start with 22, which was the earliest start, which was the earliest start of this node, the last node, finishing node. You put the latest finish the same as the earliest start of this node, 22. Here during forward pass, we kept on adding the durations. Now during backward pass, we'll keep on subtracting the durations. Subtracting the duration from earlier node to find out the latest finish of the next node. From this node, the latest finish is 22. Subtract 6. What do you get? 18. Sorry, 16. 22 minus 6, you get 16. So put 16 here. Put 16 here. And 22 minus 5, you have 17. Put 17 here. Put 17 here. And from 16 again subtract 2, what do you get? 14. So put 14 here. This 14 is latest finish of this node. Now again you have a conflicting situation. What you had conflict during forward pass, now during backward pass you have a conflict when you have burst activities, burst node. See, this node is actually burst node, or you have the activities which is coming out, which is coming out from this, emanating from this node. So this node is called burst node, and here the conflict is like this. If you deduct 6 from 14, you have 8 as the latest finish of this node. If you deduct 4 from 16, you have 12 of latest finish of this node. And if you deduct 10 from 17, you have 7. So what are the latest finish? By this way, the latest finish is 8. By this way, latest finish is 12. By this way, latest finish is 7. So here you take the lowest one. During forward pass, we took the highest one, highest of the earliest starts. If you have number of earliest starts for a node, you take the highest one. Now during backward pass, if you have more than one number of latest finish for a particular node, you will take the lowest one. Remember, I repeat, during forward pass, whenever we had number of earliest starts for a node, we used to take the highest one. Now during backward pass, if you have number of latest finish, which is more than one number of latest finish for a particular node, you will take the lowest one. So in this case, for this burst node, this is the burst node, in this case, where you have 3 activities emanating from this node, this is the burst node, you have more than one latest finish for this node. So one latest finish is 14 minus 6, 8. Another latest finish is 16 minus 4, 12. Another latest finish is 17 minus 10, 7. So you will take the lowest one, 7. 7 is the lowest one, you will take 7. Right? Understood clearly? Okay. Now for this node is very simple. 14 minus 3. So obviously 11 is the latest finish for this node. And for this node also 17 minus 6 is again 11 is the latest finish of this node. And again you have a situation of having more than one latest finish for this node. For this node again you have more than one number of latest finish for this node. Why? This is again a burst node. This is again the burst node for which you have number of latest finish for this node. See how it is. 11 minus 2, you have latest finish 9. 11 minus 2, 9. 11 minus 8, 11 minus 8, 3, you have latest finish 3. And 7 minus 7, you have latest finish 0. So which is the lowest one? It is 9. It is from this side it is 11 minus 8, 3, and from this side it is 7 minus 7, 0. So you have the lowest latest finish for this node. The starting node is actually 0. The lowest one is 0. So this way we have calculated the earliest start and latest finish. Earliest start by forward pass calculation and latest finish by backward pass calculation. And this way we have completed the nodes by node numbers and earliest start and latest finish. Node number 1 has earliest start 0, latest finish 0. Node number 2 has earliest start 2, latest finish 11. Node number 3 has earliest start 7, latest finish 7. Node number 4 has earliest start 8, latest finish 11. Node number 5 has earliest start 13 and latest finish 14. Node number 6 has earliest start 17, latest finish also 17. Node number 7, earliest start 15 and latest finish 16. And last, the node number 8, both has earliest start and latest finish 22. Now, after doing all this, we will try to find out which one is critical path, and for this you have a particular set of rules. What are the rules to find out critical path at this stage? Let us see the rules. We have finished drawing these nodes, and now we will see the rules of finding the critical path. I have already discussed, but again let us see what is here written. During forward pass, start at the first event with 0 earliest start and keep on adding the activity durations for the earliest start of the rest of the events. During backward pass, start at the last event with the earliest start of the event as the latest finish of the event, and keep on subtracting the activity durations for the latest finishes of the rest of the events. This we have all done. We have understood and we have all done all these things. During forward pass, I have also explained, during forward pass, take the highest earliest start. Take the highest earliest start time for a merge event or merge node. I have already explained that during forward pass, what do you take? Take the highest earliest start time for a merge event, very important. And during backward pass, I have already discussed, but again I am highlighting all these things for you to remember, so that you can remember better. And during backward pass, take the latest finish time for a burst event. We already know very well what is merge event, what is burst event. For a merge event, you take the highest earliest start time during forward pass, and for a burst event, you take the lowest latest finish time during backward pass. Clear? And also I have already discussed let us highlight the issues. During forward pass, what happens? You start with 0 things, and during backward pass, what happens? You start at the first event, here you start at the last event. Okay, so these are the things we have already discussed. Now, step 2. In step 2, find the critical path. And to find the critical path in step 2, what do you have to do? To find the critical path in step 2, you have to follow these rules actually. You have 2 rules. Following rules apply in locating the critical path of a network. What are the rules? These rules are actually very simple. Just you understand and you can apply this very simple. The first rule is, if for an activity earliest start time equals the latest finish time at both head and the arrow and the tail of the arrow. Head of the arrow, tail of the arrow. What is said? For an activity, earliest start time equals the latest finish time. Earliest start time equals the latest finish time at both the head of the arrow and at the tail of the arrow. Okay. Earliest start time equals the latest finish time. Let us see. In this diagram, what we have done just right now, the first condition is earliest start time equals latest finish time at both the head and arrow. So, see, if we take say this activity at the both head and tail of the arrow. So this is the head of the arrow, this is the tail of the arrow. At the head of the arrow, what is your earliest start time? Earliest start time is 17. And what is the latest finish time? This is also 17. Understood? For this activity, at the arrow head, at the head of the arrow, you have earliest start time 17 and latest finish time is also 17. And for this activity, at the tail of the arrow, at the tail of the arrow also, you have earliest start time 17, latest finish time, earliest start time 7 and latest finish time 7. So both are 7. That means equal. That's what it is said here. Your earliest start time must be equal to latest finish time. Earliest start time equals latest finish time where? At both head of the arrow and tail of the arrow. So it is clear. For this activity, this is the arrow activity. At the head of the arrow, earliest start time and latest finish time both are 17. And at the tail of the arrow, the earliest start time and latest finish time both are 7. That means equal. So this is the first condition to become an activity as critical activity. To become an activity as critical activity, this is the first condition. That is a necessary condition. It must be that. This is the first condition. The head of the arrow will have same earliest start and latest finish time, and tail of the arrow also will have same earliest start time and latest finish time. Clear? And if this is fulfilled, we can say that necessary condition is fulfilled. And the second rule, sufficient condition, is what? Sufficient condition says that if the first condition is met, the second sufficient condition is the difference between earliest start time at the head of the arrow. So what is it? Difference between the earliest start time at the head of the arrow and earliest start time at the tail of the arrow is equal to the duration of the activity. So actually what it says, duration of the activity is, yes, earliest start time at head. That means in short we can write duration of activity equals to earliest start time at the head, ES at head, minus earliest start time at the tail of the arrow, ES earliest start time at tail. So this is the sufficient condition, or you can say rule number 2. Duration of the activity must be equal to earliest start at head of the arrow of that activity which has the duration D. So D must be equal to earliest start time at head of the arrow minus earliest start time at the tail of the arrow. Right? So let us see whether this second condition, sufficient condition, is fulfilled. First condition was fulfilled for this activity. For this activity, sufficient condition was, necessary condition was, what was the necessary condition for this activity? The necessary condition for this activity was at the head of the arrow, earliest start and latest finish must be same, and at the tail of the arrow also, earliest start time and latest finish time must be equal. So necessary condition was fulfilled. Now let us see for this activity where the second condition, the sufficient condition, is fulfilled. Sufficient condition was duration, that is this 10. Duration must be equal to earliest start time minus earliest start time. Earliest start time at head of the arrow, earliest start time at tail of the arrow. The earliest start time here is 17 and earliest start time here is 7. So 17 minus 7 is 10. So this second condition, sufficient condition, is also fulfilled. D is equals to ES at head minus ES at tail. So for this activity, the second condition is also fulfilled. So safely and confidently we can say this is a critical activity. This is a critical activity. Okay? So let us find out which are other critical activities applying this rule. Applying this rule, which are other critical activities? So now let us examine each of the activities individually, separately. Activity A. Activity A. For activity A, so here at the arrowhead, earlier start and latest finish are not equal, although here it is equal, but at the arrowhead it is not equal. The condition was at the arrowhead and arrow tail, in both the cases you should have earlier start and latest finish must be equal. So at the arrowhead it is not equal. So necessary condition is not fulfilled. So we don't need to see the sufficient condition, because necessary condition is not fulfilled. In fact, the other condition is also not fulfilled, because other condition was earliest. Other condition here actually other condition is fulfilled, right? Other condition was, second condition was duration. Duration will be equal to earliest start minus earliest start at head minus earliest start at tail. So it is this. This condition is fulfilled. Second condition is fulfilled, but the first condition must be fulfilled before you come to the second condition. Second condition is fulfilled. Earliest start 2 minus earliest start 0. So 2 minus 0 is 2. This is okay. But the first condition is not fulfilled. First condition is at both arrowhead and arrow tail, the earliest start and latest finish must be equal, which is not there. So this is not critical activity. Here the arrowhead has earliest start 13 and latest finish 14. Here also earliest start 2, latest finish 11. So not equal. So first condition itself is not fulfilled, not critical. It is also not critical. 15, 16, 13, 14, not critical. See here, in case of activity B, at the arrowhead, earliest start, latest finish equal. Arrow tail, earliest start, latest finish 0, 0 equal. And also the duration is the difference between earliest start at arrowhead minus earliest start at arrow tail. Earliest start at head is 7. Earliest start at tail is 0. 7 minus 0 is 10. Is 7, which is the requirement. Earliest start at head minus earliest start at tail must be equal to the duration of the activity, which is 7. So safely, confidently you can say this is critical activity. Right? Examine this activity. Obviously, earliest start, latest finish are not equal, so this cannot be critical activity. The first condition is failed. In this case, of course, although the arrowhead has equal earliest finish, earliest start and latest finish, but the arrow tail has different earliest start and latest finish. So again, the first condition is failed, so this is not critical activity. Now come to this one. We have checked this one. This one, let us check. So earliest start is 13, latest finish is 14. So not critical. This is also not critical. 15, 16. This is also not critical. We have checked all this, and here, although the arrow tail has equal earliest start and latest finish, but the arrow head has different latest start and latest finish. Earliest start and latest finish. Different earliest start and latest finish is different, so this is also not critical. So we have found this is critical, this is not critical, and come to this one, the last one. No, this is not the last one. Before that, let us see this one. This activity, activity K. Here again, although the arrowhead has equal earliest start and latest finish, but arrow tail has different earliest start and latest finish, 15 and 16. So this is also not critical. Now come to this activity. It's clear this is a critical activity because arrow had same earliest start and same latest finish. Arrow tail also has same earliest start and latest finish. The first condition is fulfilled, and second condition is also fulfilled because the duration 5 equals to earliest start of this node minus earliest start of this node. Earliest start at arrowhead minus earliest start at arrow tail. 22 minus 17 is 5, the duration. So this is also a critical activity. So we have in this diagram three critical activities forming the critical path. So students, we have seen how critical activities are identified, and that way how a critical path is identified, the critical path of the project, the entire network. We have seen that. Now this is our critical path. This by node 1, 3, 6, 8 and by activity B, F, J. This is our critical path. So you can write here the critical path is by node 1, 3, 6, 8 and by activity B, F, J is the critical path. 1, 3, 6, 8 and by node by activity B, F, J. These are the critical activities and this is the critical path. Then this critical path is having total duration 22 days, total time 22 days. How it is coming? Activity B has 7 days duration, activity F has 10 days duration, activity J has 5 days duration. Total 7 plus 10 plus 5, 22 days. So 22 days is the duration of this critical path, and obviously this is the duration of the project. 22 days duration of this critical path. And remember, all other activities of this network, activity A, D, I, K and all that, all other activities other than the critical activities which are on the critical path, other than the critical activities, all other activities are non-critical activities. So this is how we have learned how to identify a critical path. So this is the second method. In the first method also we found the critical path by comparing the total duration of all the paths. Duration of this path 13 days, duration of this path 21 days, 17 days, 22 days, and last this path having 19 days. Comparing all these durations, we found this path 1368 BFJ has duration 22 days, which is the longest duration, and that's why this path will be called critical path. BFJ by activities will be called the critical path. So this is the first method by which we identify the critical path, and we have understood also the second method by which we found the critical path. So for sum up, let us try to sum up the second method again, because in the second method actually the most important thing is to understand the forward pass and backward pass. I'm summing up, for the second method, we apply the forward pass to identify the start. To identify forward pass, you apply to identify the earliest start. Forward pass, you apply to identify the forward pass. This is what the forward pass. Forward pass you apply, forward pass calculations apply to identify earliest start, and backward pass apply to identify the latest finish. And forward pass start at first event with 0 earliest start. Backward pass start at last event with the earliest start of the event as the latest finish. During forward pass, the most important, during forward pass, take the highest earliest start time for a merge event, and during backward pass, take the lowest finish time for a burst event. We have all discussed and we have all understood. So this is just sum up. And finally, after you identified earliest start and latest finish for each of the nodes, you have to identify the critical activities. Now, to find out critical activities, there are two rules: necessary conditions, rule number 1, and sufficient condition, rule number 2. Necessary condition says an activity to become a critical activity, the necessary condition is at the tail of the activity arrow, the earliest start and latest finish must be equal, as well as at the head of the activity arrow, again the earliest start and latest finish must be equal. So this activity to become critical, the first condition is the tail of the arrow or activity. At the tail of the arrow or activity, the earliest start and latest finish must be equal. Similarly, at the head of the arrow or activity, the earliest start and latest finish must be equal. And if this condition is fulfilled, the necessary condition, then this may be called critical activity. But the sufficient condition says, of course, you have to fulfill both the conditions to become an activity, critical activity. The sufficient condition, the second condition, it says a duration of the activity. If this is the activity, the duration of this activity must be equal to earliest start at the head of the arrow minus earliest start at the tail of the arrow. Earliest start at the head of the arrow minus earliest start at the tail of the arrow must be equal to duration of the arrow activity, duration of the activity. This is the second condition. So both these conditions to be fulfilled, and applying these rules we have identified the critical activities. See, these are the critical activities where the first condition, earliest start and latest finish at arrow head and tail must be equal. So at the arrow head, for this activity, earliest start, latest finish both are 7, earliest start, latest finish both are 0. For this activity again, at the arrow head, earliest start, latest finish both are 17, and the tail of the arrow has earliest start, latest finish 7 equal. And for this activity, earliest at the arrow head, earliest start, latest finish 22, earliest start, latest finish the tail of the arrow 17 equal. So these are the three activities which are critical activities. And the second condition also fulfilled here. Second condition says duration of the activity must be equal to earliest start at the head of the arrow minus earliest start at the tail of the arrow. Earliest start at the head of the arrow, earliest start at the tail of the arrow. So here, see, earliest start at the head of the arrow is 7 and earliest start at the tail of the arrow is 0. 7 minus 0, the duration is 7 equals to duration of this activity. Here also, earliest start at the head of the arrow is 17 and earliest start at the tail of the arrow is 7. 17 minus 7, 10 is the duration of the activity. So critical and second condition fulfilled. And here again, at the head of the arrow, earliest start is 22. At the tail of the arrow, earliest start 17. So 22 minus 17 is 5, which is the duration of the activity, and that way the second condition is fulfilled. And applying all these rules and conditions, we have identified the critical activities and the critical path, which is 1, 3, 6, 8 by nodes and BFD by activities, and the duration of this activity is 22 days, which is also the duration of the project. And all other activities are non-critical activities. That's all for this class today, students. In the next class, we'll take up the issue of crashing the critical path and crashing the project duration. Means crashing the project duration means reducing the duration of the project. Here we have found the duration of the project is 22 days. In the next class, we'll see by crashing how much we can reduce the duration of the project from 22 to lesser number of days, lesser duration by crashing. That is all called crashing. We'll see in the next class how the total duration of the project can be crashed to a lower one, optimum one. We'll see in the next class. So students, that's all for this class. Thank you for listening and sharing this class. If you liked this class, like this video, please press the like button and please subscribe my channel. Thank you very much, students. Thank you.